Optimizing your CPU usually goes in two directions. Either you want to increase performance, called overclocking, or decrease power draw, temperature and noise, usually referred to as undervolting, although voltage tweaking is not the only factor here. Actually, you can achieve the benefits of both directions partially, that is having more performance while reducing power draw. The goal of this video is mainly to improve performance. We will not use Ryzen Master because it has no curve optimizer support for Ryzen 7 9800X3D CPU, so tuning will be done the good old BIOS way. To get into BIOS, I need to smash Del button during boot, which is specific to my motherboard, the ASROCK X870 Steel Legend Wi-Fi. Watch my previous video for more details. First of all, make sure that the AMD EXPO RAM profile is enabled in your BIOS, if your RAM supports it. Don't forget to save your changes. If you have a dedicated GPU, which is not my case yet, turn off the integrated GPU to free up its resources, like power and heat budget, for the processor cores. Let's locate PBO, Precision Boost Overdrive, which should be in Advanced, AMD Overclocking, in our BIOS and change its value to Advanced, which will unlock CPU tuning settings. In this submenu, there are a few easy steps to take and one potentially difficult one. Let's start with the easy ones. First, set PBO limits to motherboard, which should unlock max power budgets based on your motherboard's limits. This might be higher than the default defined by AMD. Next, change the value of CPU boost clock override to enabled positive, which will allow us to set max CPU boost clock override. Recommended value is 200 MHz. I wouldn't go higher, as whether your CPU cores can really achieve these higher sustained frequencies depends on specific workload, power, temperature and voltage limits. I wouldn't touch the scalar value, as it could shorten the lifespan of your CPU. So setting this higher might not result in a better performance. Also, higher frequencies require more voltage and we want to actually negatively offset core voltages, which is the difficult step. Depending on the chosen method, it can be very time consuming. There are 3.5 ways to do this. Let's go into Curve Optimizer. By the order of difficult from lowest to highest. First is all cores, second is per CCD, and the third is per core. Enabling any of these will unlock several options: Curve Optimizer sign, Curve Optimizer magnitude. For the all cores option, you will set the same value of all the 8 cores at the same time. Similarly, per CCD will allow you to set it per CCD, which is the same as all cores option, as this CPU has one CCD with 8 cores. Lastly, the per core option enables you to tweak each individual core. Choosing more granular and detailed option here will result in endless stability testing runs, as in general after each change you would like to run several stability and performance tests. The stability tests are extremely time consuming. I've done this with little to no benefit, so I strongly advise to choose the all core option. Next, set all core curve optimizer sign to negative, and then for the all core curve optimizer magnitude, I would start with the value of 15, as this seems to be stable for most Ryzen 7 9800X3D processors. There is one more tuning setting called Curve Shaper, but again, the required time to tweak this is generally not worth the benefit. Don't forget to save all changes and then boot into BIOS. For monitoring all the operational values, like temperatures, power draw, voltages, frequencies, fan speeds, we are using HVInfo64, which should have only a minuscule impact on performance. Now we will do some performance tests and then a bunch of stability tests. The more stability tests you do, the better. For mostly performance and a bit of stability testing, run Cinebench R23 multi-core and also single-core tests. When testing performance, turn off minimum test duration and run multi-core test 3 times and average the result. Same for single-core test. For testing performance, you need to set Cinebench application to high priority, otherwise you will not get the highest scores, or at least it will be very inconsistent with big variance between runs. Your system will be less responsive during tests, but for precise scores, you don't want to bother your CPU with other tasks anyway. Open Task Manager, shortcut is Ctrl-Shift-Escape, go to Details, search for cinebench.exe, right-click, set priority, high. Then right-click again to check whether the priority really changed. This needs to be done every time you launch Cinebench. Performance should remain the same or increase a bit. If you see a decrease, then you hit a limit to a certain parameter or combination of parameters in BIOS. After checking performance, run 30-minute stability test on all cores in Cinebench. There are 2 more apps used for stability testing. One of them is OCCT and the other one ADA64. ADA has a 30-day trial period, so keep that in mind before installing it. I do not advise using a popular software called Prime95, as it is randomly failing after a few consecutive runs, even on stock CPU with EXPO memory profile. For example, once it ran for 10 hours, I just stopped it, restarted the app and test, and then it crashed within 5 minutes. It was very inconsistent. And the EXPO memory profile should not be a problem, as I tested it using memtest86 and it was passing without issues. For ADA64, we want to run the system stability test with checked CPU, FPU, cache and system memory. OCCT contains several stability tests. I chose to run these: LIMPAC, CPU plus RAM on default settings, then CPU on normal mode, and then CPU on extreme mode, and then again CPU on extreme mode with SSE instruction set and with the thread setting set to core cycling value, which cycles through each core, while previously the auto value on this thread setting actually stresses all cores at the same time, and this is used for all the previous mentioned tests. Running the default duration of 1 hour for all stability tests whilst finding the voltage offset is sufficient. After you think you found it, it is a good idea to run a few longer tests. For example, 12-hour system stability test in ADA64, and also try different test configurations. If everything is passing and you see no performance decrease, then increase the all-core curve optimizer magnitude by 5 and repeat performance and stability testing until any of the stability tests fails. At this point, you have reached the maximum undervolting potential, in other words, the maximum negative voltage offset, so decrease the all-core curve optimizer magnitude to its previous stable value. For my specific setup, I was able to achieve a negative 20 voltage offset. Stock multi-core scores without running Cinebench in high priority shows a variance of 250 points, and at best it performs 400 points below stock with high priority. On average, it is performing 2.5% worse. This is why setting high priority for the Cinebench process in Task Manager is important. Gains do not seem to be significant in Cinebench, other workloads may differ. Relatively to stock, it is a tiny 1.2% performance increase for multi-core and a slightly better 3.7% increase for single-core score. Lastly, check out some of the sensor values for Cinebench multi-core performance tests. Notice the core voltage, VID, effective clocks, CPU temperature and power draw. As you can see, for 15 watts, roughly 12% more power, that is 6 degrees worse temps, we got a better score by 1.2% in this particular ore-core rendering workload. Finally, keep in mind that the performance benefits might be higher in other workloads, like gaming, where quite often high single-core boost clocks matter. Also, we are using the integrated GPU on the same CPU chip due to a lack of discrete one, which might have influenced these results in a negative way.